We're looking at page 98. This is over what we call the rational root theorem. So, last time we were together, we talked about how we can find the possible rational solutions. We talked about how the factors of the constant term here divided by the factors of the leading coefficient, how that will tell us all the possibilities for the real zeros. The rational solutions are the same thing as the real zeros. So let's look at this problem down here. I want you to write this down. We want to find the real zeros for f of x equals x cubed plus 10x squared plus 31x plus 30. So when we're finding real zeros, it's as if we were taking this equation, instead of setting it equal to f of x, we're going to set it equal to 0. That's where we find our real zeros. Now, we want to find some possibilities, because right now, if I look at this, this can't be factored. If I try grouping, it's just not going to work. If I factor out an x squared, I'll be left with x plus 10. I can't factor anything out of here. So grouping doesn't work. So I have to think, what are possible solutions? The way that I do that is I look at my p-values. The p-values are the factors of 30. So the factors of 30 are plus or minus 1, 2, 3, what else? What other numbers? 6, what else? 5, 6, what else? 10, 15, and 30. So lots of possibilities. Then we have to divide. Q is always going to be the factors of the leading coefficient. Well, that's just a 1. So right here, plus or minus all of these numbers, these are our possible real zeros. I could use synthetic division. I could start with positive 1, positive 2, positive 3. I could check all those, and I want to know if they equal 0. But think about this with common sense. If these are all positives, if I plug in 1, let's look what's going to happen. I'd have 1 plus 10, that's 11. 11 plus 31 is 42. 42 plus 30 is 72. I'm not going to get 0, am I? What if I plugged in positive 2? Is it possible I could get 0? No, because all these are positives. It's just going to keep getting bigger and bigger. Same thing for 3, 5, 6. All those positive numbers, it's impossible they could give me 0. So what else could I check then? Negative 2, or I could check what else? Negative 1, right? Negative 1 might even work. I can just plug in negative 1. Negative 1 cubed is negative 1. Negative 1 squared is 1 times 10. Negative 1 times 31. And then plus 30. So let's see. This would be negative 32. And this would be 41, or I'm sorry, 40. So we'd have negative 32 plus 40. Is negative 1 going to work? No. So I'm going to try negative 2. I don't really want to plug it in again, so I'm going to use synthetic. So I'm going to go negative 2. I put my 1, my 10, 31, and 30. I'm going to bring this down. I get 1. I multiply and add. I multiply and add. I multiply. Great. Why do I say great? Yeah, it works. As long as I get 0, then I know that that's going to give me an answer of 0 when I plug in negative 2. So therefore, one of my zeros is x equals negative 2. Now I have to find my other ones. Well, how can I find my other ones now? Remember that this is what's left after I take out the factor. I can solve this, can't I? Because what does this represent? Which spot?
X squared.
X squared. And this would be x. So now what I'm left with is, I'm going to come down here and squeeze this in, x squared plus 8x plus 15 equals 0. How can I solve this? Well, I can factor it. Are there numbers that multiply to be 15 and add to be 8? 5 and 3, plus and plus. And so what are our other zeros? Yes. Okay, so those would be the 3 zeros. And remember, whatever this power is, that's how many zeros I should end up with. Now, something could be a solution more than once, but I have to have a total of 3 zeros, and I do, so I know that this is correct. What if I felt like I might have made a mistake here with my factoring? How could I check this? Plug it into the calculator. Well, I could plug these in individually, couldn't I? Kind of hard to do. Couldn't I just put this into y sub 1 on my calculator and look at my table and see if they equal 0? And if they do, then it works. Okay? So using your calculator can be a nice way to check. All right, let's go on over to page, actually there's nothing on 99, so skip on over to page 100. Okay, I think we did this one together, didn't we? Do you feel like you could do it a little faster now? The last time we did it, I know some people missed it. Can somebody explain why to me, why we chose letter D was the one that was not possible? Do you remember why? Go ahead, Zach.
So it would be plus or minus 7 and 1 over plus or minus 1 and 2. And if you divide 7 by 1, it's 7, so that's the solution. 7 by 2 is 3.5. 1 divided by 1, or 1 divided by 2 is 0.5, and none of them is equal 3.
Correct. Okay, very good. All right, let's go down to number 12 now. I want you to change this problem. The one we have is a little too intense, so we want to do this one. F of x equals x cubed minus 14x squared plus 55x minus 42. Okay, so again, we're trying to find these real zeros. We don't want to just start using synthetic division without doing any kind of thinking. So we want to first of all try that P over Q, just so we have some idea. And we really don't have to write down all these factors. We just want to have some idea. So what are factors of 42? 1, 2, 3, 6, 7, not 8. 3 times what is 42? 3 times 14? Yeah, 14. Okay, so you get the idea. It's pretty rare that it's these huge numbers, so I'm not even going to continue, but I'm going to put dot, dot, dot. So you see the pattern there, right? And then the factors of 1 are just going to be 1. So these are going to be our possible zeros. And like I said, it's rare that it's going to be 24 or 48. So now we're going to do some common sense here and think, okay, what about positive 1? I always just plug in 1 because it would be 1 minus 14, that's negative 13. Negative 13 plus 55. Ooh, negative 13 plus 55 is what? 42. Minus 42 is 0. So what happened there? What was my first solution then? 1. Okay, do you see how I did that? I didn't even have to really do much work at all. So now I know 1 is going to work, but I want to go ahead and do my synthetic division. So I do 1, negative 14, 55, and negative 42. I bring down the 1. I already know this should work because I just did it. So that's 1, that's negative 13, that's negative 13, that's 42, that's 42, and that's 0. So why did I do that if I already knew it was a 0? Yeah, I have to have another equation that I can solve. So now if this was x cubed and I divided by an x, this is going to be the x squared. So I'm going to have x squared minus 13x plus 42 equals 0. So now I see if this can be factored, x and x, what are 6 and 7, right? And they're both going to be what? Minus. So then what are my zeros going to be? 6 and 7. And then I check. I got 3 solutions. That's what I'm supposed to have. So that is probably correct. We could put this into y equals, check the table, and we could see those are indeed the solutions. Okay, a little bit more challenging now. write a polynomial function g of least degree that has rational coefficients, that just means fractional or real numbers, integer numbers rather, a leading coefficient of 1, and has zeros of -5 and 4 plus radical 2. Now, this would be my k value. So I know that one of my zeros is -5. What was that as a factor then?
+1.
Yep, it would be x plus 5. Now, one way I could do this would be to say, okay, another one I would have would be x minus 4 plus radical 2. What did we say earlier? That if 4 plus radical 2 is a solution, because of the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, what has to happen if 4 plus radical 2 is a solution? So is 4 minus radical 2. And that was back here in the notes. I didn't make a big deal about it, but let me talk about it again. It says it right here. If a plus radical b is a solution on page 98, then a minus radical b is also going to be a 0. So the conjugates just means you change this middle sign. So if a plus radical b is a 0, so is a minus radical b. Okay, so if this one is a solution, so is this one, unfortunately for us, because that would mean that we would have to multiply this whole thing out to get our equation. Not much fun. But here's what I could do. I can look at 4 plus radical 2 and 4 minus radical 2, and I can use the sum and the product like we talked about in the warm-ups. So what do we get if we add those two together? 8, right? What do we get if we multiply them? A little tougher. I have to do the first times the first is 16. The outers would give me -4 radical 2. The inners would give me +4 radical 2. The last times the last, what's radical 2 times radical 2? Just 2. And so what's this going to simplify to? It's going to just be 14, isn't it? So our product is 14. Well, earlier we talked about this sum and product rule. We said that if we know the sum and the product, that it's going to end up being x squared minus the sum, x, plus the product. That's going to be what the equation was. Remember how we said that b is always negative the sum and c is always the product? We said that in the warm-ups. So now look what I can do. I can say, oh, okay, x plus 5, that has to be a factor. But so is x squared, can you guys do the rest of it? Minus 8x, and then what? Plus 14, good. So now this is going to be my function, and this is what I have to multiply out. That's a lot easier to multiply out than this, okay? So multiplying this out, just do this on your own. And then just simplify it. And so that's going to be the solution. That's going to be the polynomial function g, I called it g, of least degree, 3 is my degree, that has rational coefficients. I just make sure that these are not radicals, and they're not. A leading coefficient of 1, it's got that. Okay, so it meets all the conditions. The reason they say of least degree is because really you could say, well, this factor could be cubed, you know, but you don't, they're saying of least degree, so that's how you know you don't have to do that. All right, let's look at number 14. What are the real zeros of the function? So you look at the graph. Okay, so x equals -6. That's one of them. What's this one going to be? X equals 0. Good. Now, remember we talked about yesterday, if it goes through the function, then it has to be to the odd power. So this must be a solution an odd number of times, right? But what about, oh, I'm sorry, I looked at that wrong. I meant to put it here. This -6 is going through the function, so this has to be a solution an odd number of times. But what about 0? What do we say when it bounces or when it just touches the axis? When it just touches the axis, it was even. So this must be a solution an even number of times, like 2 times, 4 times, 6 times, 8 times, etc. So now let's see what it says. Write an equation of the cubic function in factored form. Cubic. What's our degree if it's cubic? 3. So my equation has to be y equals x to some power. And then what would this have to be if the answer is -6? What was the factor? X plus 6. I have to have a cubic. Right now I just have a quadratic. It's just squared. So what else should I do? Square which one? The first one only, because it was a solution an even number of times. And now I have a cubic function. See how if I multiplied it out, I'd end up with a 3rd degree polynomial? Okay? Any questions? So the big takeaways there. If you're given an irrational value here, then the conjugate of it would also have to be a solution. On that type, you want to find the sum and the product, because then you can find that equation very easily, that factor right here, easily. Then when you multiply it out, you can get that final equation in that form that's necessary. Okay? Also, the other thing we talked about that's important, when we have to go find the real zeros, use common sense. There's a long list of possibilities. You don't want to start at 42. It's pretty unlikely 42 is going to be a solution. You want to start small. Maybe you should just plug in 1 and -1 because they're easy to plug in, and then do your synthetic division. Okay? Any questions? All right. Let's stop there and we'll take a look at the homework.